Okay, well, all going well. That should be 1.5 inches. Nice and round. We're half a thou up on size, but I think we can be forgiven for that. 115 diameter by 50mm long. Cast iron. Well, okay, Mr. Bozo here forgot to turn the camera on, didn't he, when he took the first cut through? So I'll re-explain what I've explained before that never got recorded. So we have our boring bar set up on an angle going into the hole. I've used an old tip which I've ground a large radius on. I'll show you that when we come out to take a measurement. Now we've touched off, set everything at 0. We've set our dial indicator on the edge of our spherical race here. Everything's on 0 there. So as the traverse, as the carriage traverses along, we make adjustments on the cross slide to keep the indicator on 0. So as the indicator we keep on 0 follows the profile of the ball, we'll mimic that profile inside our housing, hopefully. So we'll take another cut and see how we go. All the cuts are taken on the compound, and we keep going back to 0 on the cross slide for our starting point. It's a bit like threading, so same sort of principle. Okay. Okay, well, all bar the 6 holes we have to do on the PCD around the outside, 6 countersunk holes. This part's completed. This is the outer race for the bearing. So that's our spherical bore inside, and on the rear that's our entry slot that we've machined in for the ball to go in. So what happens is we get our ball, it goes into the slot, snaps in, rotates around half a turn. Nice big chunk of 7000 series Kaiser aluminum from the USA. chicken. Investigating some 50 taper arbors. Making sure they're fit for use. Right, we'll double check our depth using our depth mic. According to this, we're there. So what we can do now, we'll just knock the sharp edge off here. Okay, well, we'll pull her out. Now our radiuses are done. She's got all nice curves, all blending and perfect. Yeah, no, all looking good. I'm going to grab the chuck key. Fat lot of good that'll be. Nothing like a bit of friction turning. Oh dear. Machinery's handbook. They're gold, you can't be without one.
over the shaft. So that's dead on 1 inch. We'll try that shaft in it. Beautiful.
Let's do it. Boom. There it is. Project X in the flesh. So what this tool does, it's a milling machine head tramming tool. It'll fit in virtually any milling machine. So we had a shaft coming out of the quill, going into a spherical bearing, which is in a base plate. Then we have our indicator mount assembly on the side. So at the end of the day, what we do when we want to tram our head, we loosen off the head mounting bolts and we use our table travel in either direction. That controls the tilt of the head in a precise manner, not like the way we usually do it. Small tap tap hammer, tap tap here and a tap tap there, or a tap 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 anywhere. So what we do is we set 0 on our dial indicator, we bring our arm across, take note of the reading, then simply move the table either backwards or forwards till we split the difference between the reading and the 0. Then we just tighten the head back up, go around and recheck, make sure we're on the same reading. Same reading, job done. Now, for a milling machine where the head nods as well, I mean this one doesn't, it's the same procedure. You zero your indicator there, bring it round to the back and use your other travel here, move the table in and out, and that will move the head in and out to do that reading. How simple is that?